So let's begin with mole concept, and we'll start off from Dalton. It's always important to know a little bit of history, right? I know this is chemistry class, but to know where you're going, you must know where you're coming from, right? Shashi Tharoor says this a lot. So what did Dalton say? I won't go too much back in history, right? I'm not going to the medieval ages. I'm not going to start by saying that the 5 elements are earth, fire, water, and wind. I'm not going to start that way. We'll start with Dalton's theory, right? What did Dalton say? Do you know? You must have, yes? Yes, he did say that. Dalton first said that any matter is composed of tiny, indestructible particles, which he called atom, right? Basically, let's say if I have this pen, right, and I keep breaking this pen down into smaller and smaller and smaller particles, eventually I will come to the smallest particle possible, which cannot be further broken down. And this smallest indivisible particle he called atom. So write down the first postulate that matter is made up of tiny, indivisible particles called atom. All matter is made up of tiny, indivisible particle called atom, right? Another important thing regarding note taking, right? You have to write down as I teach, right? I'm not going to give you class notes because it is important that you make good class notes. When you have to revise any chapter, the class notes will be all you need, right? You don't have to go to a book always. The notes are going to be self-sufficient. Okay? If you have any doubts in between, you can always raise your hand and stop me. You can interrupt me in class, it's fine, right? And I will keep asking if you're following or not, so that won't be a problem. So matter is made up of tiny indivisible particles called atoms, right? Is this true? No, right? The atom we know now is divisible. The atom can be broken down. It is made up of electrons, protons, and neutrons. And now we know even further subatomic particles. There's the Higgs boson, there's up quarks, down quarks, fermions, and quasars. There are so many particles. There are 15, 16 more subatomic particles, right? But in our syllabus, we will be only dealing with protons, neutrons, electrons, and positrons. Right? These 4 subatomic particles are in the purview of our syllabus. The other subatomic particles are further studies, not in 11 and 12, right? But this is now false, right? We now know better. The atom can be divided, but Dalton did not know that. Dalton said that the smallest particle of matter is atom. Usse chota kuch nahi ho sakta, right? Next, Dalton also said that atoms of the same element are always similar. Atoms of the same element are always similar. What does he mean by this? Dalton is saying that if, let's say, I have some iron here on Earth and I keep breaking it down into smaller and smaller particles, and eventually I come to an atom of iron, right? If I have some iron on Mars, and I keep breaking it down and I come to an atom of iron, these 2 atoms are going to be same, right? The atom of iron here on Earth will be the same as the atom on iron on Mars or anywhere else in the universe, right? The atom of a particular element is the same everywhere. Is it true now? Why not? Isotopes, yes. The same element can have different kinds of atoms, right? We know that hydrogen could be protium, deuterium, and tritium. There are 3 different atoms, all of which represent the same element, hydrogen. So it is now false, right? This is no longer true. This is now false. Next, Dalton also said that it is the atoms which take part in chemical reactions. Right? Atoms take part in chemical reactions, and this postulate is still true, right? We now have a better understanding of chemical reactions, and the chemical reactions take place at an atomic level. So this is still true today. Then there are a couple of more postulates, like Dalton says that the atoms combine in a fixed ratio to form compounds. atoms combine in a fixed ratio to form compounds. Anyway, so this was Dalton's atomic theory. Many years, by 1800 something, was Dalton's atomic theory. And for a long time, this was the leading theory regarding matter, right? So different elements have different types of atoms, right? Which is the lightest element? Hydrogen. So which atom is going to be the smallest? Hydrogen, right? Different elements have different atoms. So which is going to be the smallest atom? It is going to be hydrogen, because hydrogen was the lightest element and uska sabse chota particle must be the smallest there is, right? So the smallest particle was hydrogen and isse chota aur kuch nahi tha, right? But then came another scientist, Faraday. Yeah, atoms can neither be created nor be destroyed. Now we'll come to the next scientist, Faraday. What was Faraday working with? Do you know? Have you heard of Faraday? What was he working with? Electromagnetism. Yes, Faraday was working with electromagnetism. He was obsessed with electricity, right? He was very interested in electricity. He did not have a lot of formal education, but he loved performing experiments. And what he did was, he wanted to try and make electricity travel through vacuum. That's what Faraday was trying to do, right? We know that electricity can be conducted through wires, right? And he wanted to make electricity travel through vacuum. So what he did was, he took a tube, right, and he pumped out all the gas from inside the tube. He put a pump here and he removed all the gas, and he placed two electrodes. Right? This is the positive end, so this is the anode. The negative end of the electrode, so this is the cathode, right? And he coated the inside of this tube with a substance. Let me write it here. He coated it with zinc sulfide, ZNS. What is the property of zinc sulfide? Yes. So if a charge hits zinc sulfide, it scintillates. There's a sparkle. ठीक है, ऐसे चमकता है अगर इस पे charge गिरता है तो. Right? So he coated the insides of this tube with zinc sulfide and he connected it to a battery and turned the switch on. He noticed that some rays were coming out. From the cathode and going into the anode, and electricity was being conducted. Now notice, between the anode and the cathode, what is present? Nothing. Right? There's vacuum. There is no medium which can carry the electricity, but still what is happening? Electricity is being conducted. अगर यहाँ bulb लगाया तो वो bulb जल रहा है, right? And he noticed, because these rays were coming from the cathode, what did he call these rays? Cathode rays. It was very obvious. Cathode से निकल रहा है, so he called these rays cathode rays, right? But before he could do further experiments on these rays, he died. And another scientist continued this experiment. His name was J.J. Thomson. Now Thomson started to analyze these cathode rays. What he did was, he placed two plates like this, a negatively charged plate and a positive plate, right? And he noticed that these cathode rays started to bend. Towards the positively charged plate. What does this indicate? The cathode rays must be negatively charged, right? Because I'm sure all of you know the mantra. Opposites attract, right? If I have a positive charge and a negative charge, they will attract each other. If I have two positive charges or two negative charges, they will repel. So like charges repel and opposites attract. So if the cathode rays are getting deflected towards the positively charged plate, then the cathode rays must be negatively charged. The cathode rays must be negatively charged. Another thing which Thomson did was he placed a mechanical wheel. He placed a mechanical wheel. It's like a pankha. Okay? He placed a mechanical wheel in the path of these cathode rays, and he observed that the wheel started to spin. Yes, he observed that the wheel started to spin. What does this mean? What does this mean? Nahi, nahi. Think about this. Suppose I have this fan, right? If I project light rays on it, will it start to spin? Of course not, right? An electromagnetic wave cannot make this fan spin. But if I throw a ball at it, right? If I keep throwing balls at it, then what will happen? It will start to spin. If I have to rotate a mechanical wheel, then I need to impart momentum. I need something which has mass to fall onto it, impart momentum, and only then it can be rotated. So what did this conclude? This confirms that these cathode rays must be made up of particles. And these particles must have some mass, right? So these particles which have mass and which are negatively charged are electrons, right? They are not rays at all. This is actually a stream of electrons. These are not rays. It is not a wave. It is not an electromagnetic wave, which Faraday had thought. Faraday thought he had discovered rays, but actually what he had discovered was a stream of negatively charged particles which had some mass. And this negatively charged particle which has some mass, Thomson called electron. This negatively charged particle which has some mass, it can impart momentum. These particles Thomson decided to call electron. Are you getting it? So it was a wrong understanding by Faraday, right? It's like this. Suppose you open your tap, right? And nal ko halka sa kholte ho. So what do you notice? Drop, drop, drop. You can identify the different drops as different particles. But if you open the tap ek saath, it is like a stream. Can you identify different particles? No. That's what happened to Faraday, right? What he observed was a ray, but it was not really a ray. It was really a stream of particles. And these particles Thomson called electron. And it's a very scientific experiment, is it not? These particles can impart momentum and they are getting deflected towards a positively charged plate. So they must be negatively charged. So these are electrons. So Thomson is the scientist who gave this name also. Right? जैसे नामकरण किया थॉमसन ने, he called these particles electron. बुआ जी नाम रखती है ना घर पे, कोई नया बच्चा होता है तो. So Thomson is the बुआ of the electron. Bad joke. Anyway, right? Why is this discovery so important? Why is Thomson's discovery of the electron so important? With the help of the amount of deflection produced and the momentum which was being imparted based on how much the fan is being rotated, he was able to calculate what is called the charge by mass ratio, right? The E by M ratio, it is also called. He calculated the charge by mass ratio or the E by M ratio, right? And by calculating this, he was able to determine the mass of an electron. He was able to determine the mass of an electron. Now these values you have to remember. The mass of an electron is 9.1 into 10 to the power minus 31 kg. Right. This is the mass of an electron. 9.1 into 10 power minus 31 kg. Yes. Why is this so significant? For the first time since Dalton, a particle was discovered which was 2000 times lighter than a hydrogen atom. Right? This is the discovery of the first subatomic particle. Till then, what was the lightest known? What is the smallest known particle? The hydrogen atom. Usse chota kuch nahi ho sakta. Right? But suddenly we have a new particle which is 2000 times lighter than a hydrogen atom. Right? So this is the first foray into particle physics. This is the first subatomic particle which was discovered, the electron, and it was discovered by J.J. Thomson. Yes, the mass of the electron is 9.1 into 10 power minus 31 kgs. Are you getting it? Another scientist, his name was Mulliken, right? He performed an experiment known as Mulliken's oil drop experiment. Now that experiment is not in our syllabus, but you can read about it online. It's pretty interesting. I'll write the name of the experiment here. Mulliken oil drop experiment. And with this experiment, Mulliken was able to calculate the charge of an electron. Do you know how much it is? How much is the charge of one electron? Yes, perfect. Charge is measured in units of coulombs, right? Coulomb was a scientist who gave us the law of electrostatic law. Anyway, so it is minus 1.6 into 10 to the power minus 19 capital C coulombs. Yes, this is the charge of an electron, which was calculated by Mulliken. Is it fine? Right. Now, something else was also going on, right? As these cathode rays, which are not really rays, right? They are not. They are actually a stream of electrons. As these cathode rays or as these stream of electrons were going through this tube, what they were doing, they were ionizing the gas inside the tube. Let's say I had hydrogen gas inside. Okay. What is hydrogen made up of? Hydrogen is one proton and one electron. This is hydrogen. And let's say this hydrogen gas is present in this tube in little amount, but it's there. And cathode rays are coming from here. Cathode rays are bombarding. They are going through this tube. What happens is this electron, it collides with this electron, which is part of the atom, and it knocks it out. Usko bahar fek deta hai, right? So if this atom loses an electron, what will be left? Simply one proton will be left. So what is happening is the hydrogen atom is losing an electron, and what is left? H plus. If an electron is lost, it is essentially just H plus. And what is H plus? H plus is just a proton. If the hydrogen atom loses an electron, it becomes H plus. And what is this? This is simply a proton. So the cathode rays were ionizing the gas. Means as these cathode rays were flowing through the CRT, the cathode ray tube, what was beginning to appear? Ions of H plus started to appear inside the tube as the cathode rays flowed through it. Now these are positively charged, right? And if this is the anode, this is the cathode. Cathode is the negatively charged terminal. Where will the positive charge get attracted towards? It will get attracted towards the cathode. ये positive charge है तो ये negative terminal की तरफ attract होगा, right? So these H plus started to move in the opposite direction, right? And what did it appear? It appeared as if it was coming out from the anode and going towards the cathode. So this was also initially observed as what? These were observed as anode rays, right? So cathode rays were going from the cathode to the anode, and anode rays were coming from the anode and going towards the cathode, right? What are the cathode rays really made up of? Electrons. The cathode rays are really made up of electrons. What are the anode rays really made up of? H plus. They are made of the ionized gas. They are made up of the ionized gas. Are you getting it? Right. But what if inside the tube I chose another gas, right? Let's say inside the tube I had helium. Helium has 2 protons, 2 neutrons, and 2 electrons. Right, I'm sure all of you know, basically this is helium, 2 protons, 2 neutrons, and 2 electrons. If cathode rays or stream of electrons strike over here and they push 1 electron out, what will I get? This will become helium plus, right? Helium plus is essentially 2 protons, 2 neutrons, and 1 electron. This will become helium plus. And what will happen is these helium plus ions will now start to move towards the cathode. They will now start to move towards the cathode. So no matter what the gas is inside, the cathode rays are always made up of electrons, but the anode rays are made up of what? The cations. They are made up of cation, and ये cation क्या होगा? That will depend on the gas which I take inside. If I take hydrogen, then the anode rays will be made up of H plus. If I take helium, the anode rays will be made up of He plus, and so on. They will keep changing. They will keep changing. So this ratio, the charge by mass ratio, the charge by mass ratio for anode rays is going to be different every time, because hydrogen atom and helium have different masses. So this ratio will keep changing. This ratio will keep changing. Are you getting it? Right. So make a note. Make a note that the E by M ratio, the E by M ratio for cathode rays, the E by M ratio for cathode rays remain the same for any gas inside the CRT. The E by M ratio for cathode rays remains the same for any gas inside the CRT. CRT is cathode ray tube. For any gas inside the CRT. Are you getting it? Full stop. The E by M ratio for anode rays depends on the gas. The E by M ratio for anode rays, the E by M ratio for anode rays depends on the gas. Is it okay? Any doubts here? All right. So with the help of anode rays, which are essentially H plus if the gas inside is hydrogen, what is H plus essentially? It's just a proton. The mass of a proton was also calculated. The mass of a proton is 1.66 into 10 to the power minus 27 kg. 1.66 into 10 to the power minus 27 kg. Right. Notice how much is the electron? 10 power minus 31. How much is the proton? 10 power minus 27. So this is much heavier, right? How much is the charge of a proton? Exactly same as the electron, but with a positive sign. So it is plus 1.6 into 10 to the power minus 19 coulombs. This is the charge of a proton, right? The third subatomic particle, the neutron, was a little more difficult to discover. It was discovered some years later. I think the year was 1916 or 18, right, around 100 years ago. And this was discovered by the scientist Chadwick. Chadwick was an assistant to Rutherford, whose experiment we will be studying. So the neutron was discovered. The mass of a neutron is approximately the same as the mass of a proton, but slightly heavier. Neutron proton se thoda sa bhari hota hai, but almost same. So it is 1.67 approximately into 10 power minus 27 kg. This is the mass of a neutron. And what will be the charge of a neutron? 0. The neutron is a neutral particle, right? So it has charge 0. Is it okay? When we are dealing with particles of this nature, right, subatomic particles, smaller than an atom also, it makes sense to create a unit which can measure the masses and the charges of these subatomic particles. For example, if let's say I want to measure my mass, okay? How will I measure my mass? What unit will I prefer? Will I measure my mass in milligrams? नहीं ना, ऐसे 10 लाख मिलीग्राम ऐसा तो मैं कुछ नहीं, जो भी ऐसा, right? What unit will I use? Kg, yes. If I get any more fat, I'll probably start measuring in quintals, right? But anyway, I have to use an appropriate unit, right? So if I want to talk about the mass of an electron, kgs is not a very good unit, is it? Right? If I wanted to write it completely, it will be 0.000000030 zeros and then 91 kg. That would be the mass of an electron. Is it sensible to measure electrons in kg? No. Right? So since we are dealing with such small particles, it makes sense to make a unit which is also suitable for measurement of such masses, right? This unit is called atomic mass unit. In short, AMU, right? This is a new unit which we are trying to create, an atomic mass unit. And why are we making this unit? Because we want to measure particles which are very, very small, which have very, very small masses. So we need a new unit for that, right? Does anyone know the definition? What is atomic mass unit? Not just any carbon atom, carbon 12, carbon 12. All right, yes, you're right. You're right. One atomic mass unit, one AMU, is defined as 1/12 the mass of one atom of carbon 12. One AMU is defined as 1/12 the mass of one atom of carbon 12. Right? Do you understand this? ये जो carbon 12 में लिखा हूं इसका मतलब क्या है? Elements in general are represented like this. If X is an element, then I will have two numbers written close to it, Z and A. Z is written here, A is written over there. What does Z represent? Atomic number. Yes, you're right. Z is the atomic number. And what is the atomic number essentially? Number of protons in the nucleus of the atom. So atomic number is number of protons. That is atomic number. Please note, atomic number is the identity of the element. Right? Atomic number is the identity. The number of protons decides what the element is. Right? So if Z is atomic number and number of protons is the deciding factor. And A over here is mass number. Right? Mass number is what? Yes. It is the number of protons plus neutrons. Number of protons plus neutrons. This is mass number. I'll give you an example. Say I have sodium and I represent it like this, 1123. Right? How many protons does sodium have? 11 protons. It has 11 protons. How many neutrons? 12 neutrons. The number of protons and neutrons don't have to be the same. Right? 11 protons, 12 neutrons. And how many electrons does sodium have? 11, because right now it is neutral. It is neutral right now, yes? So the number of protons and the number of electrons must be the same. Only then it can be neutral. So 11 protons, 12 neutrons and 11 electrons. But if I have Na plus, how many protons? It is same. Because the protons are same, the element remains sodium. That has not changed, right? Neutrons are how much? 12. How many electrons but now? 10 electrons, right? See, many things can have 10 electrons. Na plus, sodium has 11 electrons in neutral state, but if I remove one electron, it becomes Na plus. How many electrons now? 10. Na plus has 10 electrons. Neon also has how many electrons? 10. Magnesium plus 2 has how many electrons? 10. Right? Magnesium plus 2 also has 10 electrons. So 10 electrons cannot be the deciding factor on what the element is. Element कौन है? उसका अस्तित्व कौन बताता है? Proton. The proton decides who the element is, not the electrons. Right? If I have something like this, carbon 6, 12, what does this tell us? 6 protons, 6 neutrons and 6 electrons. If I gave you a random element, X let's say, and I told you 14 and 6, these were, what does it have? 6 protons, 6 electrons. Yes. What will this element be? Carbon. It will also be carbon because what is the deciding factor? Protons. The protons decide who the element is. If this has 6 protons, it will be carbon. It cannot be anything else, right? It is carbon, right? 8 neutrons, many things can have. For example, oxygen, this oxygen has 8 neutrons, right? But does this 8 neutron make it oxygen? No. Because it has 6 protons, it will definitely be what? Carbon. This is the deciding factor. The atomic number decides who the element is. Anyway, what are these two a pair of? Isotopes, right? Atoms which have the same atomic number but different mass number, they are isotopes. They are isotopes. Same atomic number but different mass number. Is it fine? All right. Now, atomic mass unit. Atomic mass unit. One atomic mass unit is 1/12 the mass of one atom of carbon 12. So which atom of carbon 12 am I taking? This one. Not the carbon 14, but carbon 12. So the definition is quite literal, right? It's like you take one atom of carbon, take one atom of carbon 12, you put it on a weighing machine, right? इसका mass पता चल जाएगा weighing machine पे रखे. This mass comes to around 20 into 10 power minus 27 kg, right? Approximately. This is the mass of one atom of carbon 12 in kgs. And then what did we do? We are like, okay, this is the mass of one atom. Let's divide this by 12, right? So 20 into 10 power minus 27 kg divided by 12. This comes to 1.66 into 10 power minus 27. This comes to 1.66 into 10 power minus 27 kg. And this we said is equal to 1 AMU. Right? This is the definition of 1 AMU. We took one atom of carbon 12, we weighed it, we found out how much is the mass of one atom, we divided that weight by 12. We divided that weight by 12 and said that, okay, this is one atomic mass unit. And now all the particles which we have, we will measure its weight with respect to AMUs in terms of AMU. So once we had defined this unit, we could now say that one proton is 1.007 AMUs. One proton is 1.007 AMUs. One neutron is 1.008 AMUs. Right? One electron is 0.0005 AMUs, etc. Right? We started to measure the masses of these subatomic particles, the protons, neutrons, and electrons in AMUs. And how do we define the AMU? एक atom लिए carbon 12 का, उसका वजन किए divide by 12, ये जो number आया, this is one AMU. This is one AMU. Yes. We know that the structure of the atom is such that the neutrons and the protons are living together inside the nucleus. And where are the electrons? Outside it, right? If I take a carbon atom, let's say, in a carbon atom, I have 6 neutrons and 6 protons inside the nucleus. And then surrounding it, I have the electrons. 1, 2, 3, 4, 5, 6, right? Let's say this is the situation. The electron has negative charge and the proton has positive charge. So the nucleus is positively charged and the electron is negatively charged. My question to you is, opposite charges attract, right? So why doesn't the electron fall inside the nucleus? Is this not a legitimate question? If I place a plus charge here and a minus charge here, they will attract each other. So total charge is balanced, okay. But the electron is going to be attracted towards the proton. Why is it not falling inside the nucleus? Huh? उससे क्या होता है? How does that help? There is an electrostatic force of attraction. Yes, very good. My question is, why isn't it going then towards the nucleus? Why isn't it falling inside the nucleus? You're right. There is an electrostatic force of attraction between positive charge and negative charge. So how are we existing? Yes. Centrifugal force. Yes. How many of you have ever been to Nico Park? Flying saucer mein baithe? What do you feel? What do you feel when the flying saucer starts to spin faster and faster and faster? You feel this force in the outward direction, like let's say, right? You get that feeling as it goes faster, you keep getting pushed outwards, right? When revolution takes place, right, you feel a force in the outward direction. This is called centrifugal force, and that is what is happening here. The electrons are revolving around the nucleus, and as a result, what is created? A centrifugal force is created. All the electrons are revolving. A centrifugal force is created. And what does this centrifugal force do? This balances the electrostatic force of attraction. And because these forces are balanced, the electron is not going and falling inside the nucleus. Make sense? Make sense? That is also the reason why the Earth is not going and falling inside the sun. If I have two objects of mass m1 and m2, they will attract each other. What will be the force of attraction? Gmm by r square. Do you know this equation? So the sun is attracting the earth is attracting the sun. Any way you want to imagine this, right? So ideally what should happen? The earth should go and fall inside the sun. But that's not happening. Why? Revolution. The earth is revolving around the sun, right? Because of which what is generated? A centrifugal force is generated which balances the gravitational pull of the sun. Right? The centrifugal force is balancing the gravitational pull of the sun, and we are not falling inside the sun. Make sense? Makes sense, right? So that's how the atom is stabilized. That's how the atom is stabilized. Now, when I teach you the chapter atomic structure, we will delve into great depth about the structure of the atom. It is very, very interesting. In fact, we'll also understand some concepts of quantum mechanics, right? When I teach you atomic structure, very, very interesting. There, I will mathematically prove to you through experiment, and I'll give you data, that the nucleus is actually very, very small, right? These 6 protons and 6 neutrons of the carbon atom are actually confined in this very small space. How small? Let me give you some idea. Imagine that the atom is a cricket stadium. All of you have been to Eden Gardens? If not, you know how big a cricket stadium is, right? So you know how big a cricket stadium is. Imagine that that is the atom. Right? And then you go and put a cricket ball in the middle of the stadium. That is how big the nucleus is. Can you visualize this? If the atom is the size of a cricket stadium, then the nucleus of that atom, where all the protons and all the neutrons are contained, how big is it? It is the size of a ball in the middle of the stadium. That's the disparity in size. That's the disparity in size, which means that the atom is mostly empty. Right? Most of the atom is what? It's empty space. It's nothing. The nucleus, which contains the protons and the neutrons, is housed where? In this tinier space. Right? If this is the atom, then this dot here is the nucleus. That's how small the nucleus is. Now, my question is, inside this tiny nucleus, I have 6 protons. Right? Are the protons not all positively charged? Yes, all these 6 protons have a positive charge on them, plus 1.6 into 10 power minus 19 coulombs. And because all of them have a positive charge, will they not repel each other? So how is the nucleus stable? How can the nucleus exist? You have explained to me that the electron is not falling inside the nucleus. There is a force of attraction, but because the electron is revolving, there is a centrifugal force which balances this electrostatic force of attraction. My next question is, how is the nucleus stable? 6 protons, all positive charge, living happily in such a small space. Are they not repelling each other? They must be repelling each other. But then why are they staying together? Yes? Think. The answer you will get here. Keep that question in mind, and let's understand another thing now. Say, in a weighing machine, I'm measuring the mass. I put in these particles. I put in 6 protons plus 6 electrons plus 6 neutrons plus 6 electrons. Right? I put all of these things in a weighing machine. I have already measured the masses of proton, neutron, and electron. So can I find out the reading in this machine? Yes. The mass is going to be 6 times the mass of a proton. How much is that? 1.007 AMUs plus 6 times the mass of a neutron, 1.008 plus 6 times the mass of an electron, 0.0005 AMUs. Right? If I add all of this, this comes to how much? This comes to 12.093 AMU. Right? 6 neutrons, 6 protons, and 6 electrons. I weigh them separately and I do this measurement. Okay. In another weighing machine, I put 1 atom of carbon 12. I put 1 atom of carbon 12. Okay. What is the mass which I will observe here? 12 AMU. It has to be, because that is the definition. 1 atom of carbon 12, the weight is going to be 12 को इस तरफ लेगा. It is 20 into 10 power minus 27 kg, which is exactly equal to 12 AMU. So this is going to be 12 AMU. Right? That is why 1/12 of it was the definition of AMU. Right? What was the definition of 1 AMU? 1/12, the mass of 1 atom of carbon 12. So 1 atom of carbon 12 is going to be 12 AMUs. Is this not strange? What is a carbon atom made up of? 6 protons, 6 neutrons, and 6 electrons. It is made up of these 18 particles. 6, 6, 6. Right? But if I weigh it, the weight is 12 AMU. But if I measure the particles separately, the weight is how much? 12.093. Right? मतलब कुछ mass हो गया. Some mass has been lost. Is that not what has happened? It's like मेरे पास 1-1 kg का 2 एप्पल था. मैंने दोनों एप्पल को खिचमिच करके मिक्स कर दिया, फिर वजन किया तो 1.8 kg हो गया. It's literally something like that which is happening. I have 6 protons, 6 neutrons, and 6 electrons. When I weigh it, it is 12.093. When I combine all of it and make it into an atom of carbon, the weight is 12. The weight is 12. Right? What has happened? This 0.093 AMUs of mass is missing. Is this mass not missing here? Yes. Where has this mass gone? This mass which is missing here is converted to energy. Right? What is the relationship between mass and energy? Einstein's famous equation. E equal to mc squared. Right? This mass which is missing has been converted to energy, and this energy is called nuclear binding energy, and it is that energy which holds these protons together. It is this energy which holds the nucleus together. So this missing mass is called mass defect. It is represented by delta M. This missing mass is called mass defect delta M. This is theoretically how much the mass of a carbon atom should have been, mth, m theoretical. But how much is the mass observed? Let me write it, m observed, OBS. It is exactly 12. So the mass defect delta M is equal to m theoretical minus m observed. The mass defect delta M is m theoretical minus m observed. इतना होना चाहिए था 12.093, but actual में है कितना? 12. Are you getting it? Right? And this mass has been converted into energy. This energy is nuclear binding energy. And you can calculate it as delta M into C square. E equal to mc squared. Right? This missing mass has been converted to energy, and it is this energy which holds the nucleus together. Right? Have you heard of nuclear power plants? Yes. What are nuclear power plants essentially doing? They are breaking the nucleus of an atom. Right? And why do they do that? Because if the nucleus of an atom breaks, what energy is released? nuclear binding energy is released, and this energy is converted to electricity, right? And this energy is huge. This energy is huge because look at the value. It is mass into c squared. What is c? It is the speed of light, which is 3 into 10 to the power 8 meters per second. There is 300000000 meter per second, and uska bhi kya ho gaya hai? Squared. Which means what? That a small mass can be converted into a huge amount of energy. A small mass can be converted into a huge amount of energy. That's why these reactions are so important to us. These nuclear binding energy is released in nuclear power plants. We break the nucleus of uranium over here, right? The uranium nucleus is broken to release energy. Are you getting it? Yes. Atom bomb. This is the energy which is utilized, right? So we learn about this in another chapter called radioactivity in class 12, right? That's in class 12 syllabus. So it's very interesting. I'll teach you how a nuclear bomb works. Like I'll teach you how to make one. Is it fine? Right. So you understand what is an atomic mass unit. We need it to measure smaller particles. But coming to our chapter now, mole concept. In mole concept, we will approximate one proton to be 1 AMU, right? We don't need the 0.007 for our level. One neutron will also be approximated to 1 AMU, right? And one electron will be approximately 0, right? 0.0005 is small, so we will assume that the electron is 0 while calculating the mass of atoms. While calculating the mass of atoms, the electron we will assume 0. But this is for this chapter, for mole concept, right? Now in mole concept, reactions take place where? Reactions take place outside the nucleus. The electrons are involved in chemical reactions. Is the nucleus involved in a chemical reaction? No. If the nucleus is involved, then it is no longer a chemical reaction. We will call it a nuclear reaction, right? And in those cases, the law of conservation of mass does not hold. For chemical reactions, you must have studied law of conservation of mass. अगर हम 10 kg से शुरू करें तो 10 kg मिलेगा end में, right? But if the reaction is nuclear in nature, then this law does not hold. So for this chapter, we are not dealing with nuclear reactions, we are dealing with chemical reactions. In chemical reactions, it is the electrons which take part. So the law of conservation of mass will hold, right? And we will be using some approximations. Proton and neutron are 1 AMU each. Electron is almost massless. But note, I am not saying that the electron has 0 mass. I am saying that the electron has 0 mass with respect to a proton or a neutron. With respect to proton or neutron, it's 0 mass. Aise it is not 0 mass. I'll give you an example. 10,000 plus 1. What can I approximate this to? 10,000? ये मैं कर सकता हूँ ना? ये 1 तो बहुत छोटा है. 10,000 plus 1 is approximately 10,000. Is this okay? Is this approximation fine? Which means 1 is a small number. 1 is a small number. But if I asked you this, 0.005 plus 1, how much is this approximately equal to? 1. Now is this 1 small? No. In fact, this is much larger. 0.005 से तो ये बहुत ज़्यादा बड़ा है. So are you getting it? The same number 1 was small over here, but it is large over here. So whenever we approximate, we are not concerned with the absolute value. We are always concerned with the relative value, right? The electron is not 0 mass. The electron is 9.1 into 10 power minus 31 kg. Electron से भी हल्के हल्के और particles होंगे. But I am approximating the electron to be 0 compared to what? Compared to a proton and a neutron. Compared to these particles, it is much lighter. So we can neglect its mass. Is it okay? So now that I have a new unit, I can measure atoms in this new unit. How do I do that? Let's say if I now ask you, what is the mass of one atom of helium? What will your answer be? What is the mass of one atom of helium? What is helium made up of? 2 protons, 2 neutrons, and 2 electrons. How much can you approximately say it is? 4 AMUs. Yes. One atom of helium is 4 AMU. Make sense? Right? What is the mass of one atom of oxygen? What is the mass of one atom of oxygen? यहाँ देख लो, mass number दिया हुआ है 15.999, which is approximately 16. So this is what? This is 16 AMU. Oxygen is this. Oxygen has 8 protons and 8 neutrons. Total is 16 mass number. 16 AMU. Make sense? Mass of one atom of sodium. Sodium is 11 protons and 12 neutrons. How much is this going to be? 23 what? AMUs, yes. 23 kg thodi hai ek atom ka. It is 23 AMUs. Now that I have a new unit, let us use that new unit, right? Is it okay? So this is the benefit of having this new atomic mass unit, because we can now measure the masses of atoms much more easily. Now, mole. We are now starting with mole. What is mole? What is 1 mole? नहीं. Avogadro number of molecules नहीं, atoms नहीं. नहीं. 1 carbon 12 atom में तो 6 प्रोटॉन 6 न्यूट्रॉन 6 इलेक्ट्रॉन है और कुछ नहीं है. Okay. 10 power 23. See, this is what I want to clarify here. A mole can be anything. 1 mole is just a number like 1 dozen. एक डजन कितना होता है? 12. अब वो एक डजन केले होने जरूरी नहीं है ना. It can be 1 dozen of anything, right? I can have 1 dozen chairs, which means I have 12 chairs, right? I have half a dozen students here, right? I have 6 students. So a dozen can be anything, right? A dozen can be anything. In the same way, a mole also can be anything. What is 1 mole? 1 mole is 6023 this many things, or 6.023 into 10 power 23. That is all. That is all. Forget about the technical definition. Okay, I'll give you the technical definition later. But 1 mole is this number, right? It could be 1 mole of anything. Please do not confuse mole and molecule. ऐसा लगता है कि ये molecule का short करके mole कर दिया, but ऐसा नहीं है, right? It could be 1 mole of anything. I could have 1 mole of pens, right? Which means simply what? That I have 6.023 into 10 power 23 pens, right? I could have 1 mole of rupees. I would be very rich, right? It could be anything. It could be 1 mole of anything. And this number is called Avogadro's number. And it is represented by the symbol N suffix A, subscript A. N subscript A, Na. As soon as you see this number, it is short for 6.023 into 10 power 23. Yes? Why this strange number? ये अजीब सा नंबर क्यों सिलेक्ट किया एवोगाड्रो ने? वो 7 into 10 power 23 भी तो लिख सकता था, या 10 into 10 power 23, 10 power 24 भी सिलेक्ट कर सकता था. Why did this number come into the picture? Why is 1 mole 6023000? Why is it this much? Yes, anyone? Why is it this much? I'll tell you why. Say I ask you this. 1 atom of helium, the weight, the mass is how much? 4 atomic mass units. So if I have 2 atoms of helium, how much will the mass be? 8 AMUs. If I have 10 atoms of helium, 40 AMUs. Tell me, what will be the mass of Na atoms of helium? What will be the mass of itne sare atoms of helium? It is going to be this into 4 AMU. It is going to be 6.023 into 10 power 23 into 4 AMUs. And do you know how much this comes to? This comes to 4 gram. This comes to 4 gram, right? And this is the reason for this number, right? If I have one atom of helium, its weight is 4 AMU, which is very easily evident from the periodic table. If I have 1 mole of helium atoms, its weight will be 4 grams. It will be the same number, just the unit will change. That is why this is used. Are you getting it? If I have 1 atom of oxygen, its weight is 16 AMU. But if I have 1 mole of oxygen atoms, itne sare oxygen atom agar ek saath hai, what is its weight going to be? 16 grams. And 16 grams is easy to measure. It is a very practical unit, right? अगर हम everyday life में chemicals exchange कर रहे हैं, then मैं तुमको कैसे दूंगा? ये लो 10 ग्राम कैल्शियम कार्बोनेट या 20 ग्राम कैल्शियम कार्बोनेट, it will be in grams. Yes, so this is a more practical unit. That is why we have this collective number. 1 mole is just a number. I can have 1 mole of anything. I can have 1 mole of atoms, 1 mole of molecules, 1 mole of electrons, 1 mole of ions, right? I can have 1 mole of anything. Is it okay? Right? And that is the beauty of this number, that 1 mole of any substance will weigh the same amount in grams as it's the weight in AMU. अगर एक एटम या एक पार्टिकल का वेट 10 AMU है, तो एक मोल पार्टिकल्स का वेट 10 ग्राम होगा. जितना भी उसका वेट AMUs में था, उतना ही उसका वेट ग्राम्स में होगा अगर इतने सारे एक साथ ले लेते हैं. Are you getting it? That's why we use this number. Now I can give you the official definition also. If I ask you, what is the mass of 1 mole of carbon 12? What is the mass of 1 mole of carbon 12 atoms? 23 unit. So how much will that come to? 12 gram. 12 gram. This will come to 12 gram. Yes. 1 atom of carbon 12 is 12 AMUs. So 1 mole of carbon 12 will be 12 grams. That's the beauty. 1 atom of sodium is 23 AMU. So 1 mole of sodium will be 23 gram. This is mole concept. Are you getting it? You have to be very clear about this. You have to be very clear about this. So the mass of 1 mole of carbon 12 is 12 gram. And this is where the official definition comes in. उल्टा सोचो अब, if I have 12 gram of carbon, 12 ग्राम कार्बन तुम एक वेइंग मशीन में मेजर कर सकते हो. If you have 12 gram of carbon, एक मुट्ठी जितना इतना सा, how many atoms of carbon have in that? 6.023 into 10 power 23. That is the definition of mole. That the number of atoms of carbon present in 12 grams of C12 is 1 mole. That is the official definition. Right? लिख लो. The number of atoms of carbon, the number of atoms of carbon present in 12 grams, of carbon 12. The number of atoms of carbon present in 12 grams of carbon 12 is 1 mole. Right? We have defined mole with the help of atoms, but 1 mole किसी भी चीज का हो सकता है. Any doubts? All clear? All clear? All right. We'll come to the first formula of this chapter. Let me ask you this. I have 60 oranges, right? Number of oranges is 60. How many dozen oranges do I have? 5. You were able to answer this immediately, right? So if I give you number of things, n let's say is number of particles. right? N is, let's say, number of particles. And I ask you number of dozens. Kitna dozen hai? What will you do? N by 12, right? Jitna bhi particle hai, that divide by 12, this will give you the number of dozens. So now if I ask you, if N is the number of particles, and if I ask you number of moles, what is 12? 12 is the number of particles in 1 dozen. So what will I have to divide now? The number of particles in 1 mole. How many particles do I have in 1 mole? 6.023 into 10 power 23. So the number of moles is number of particles upon 6.023 into 10 power 23, which I can write in short as n upon Na. And number of moles is written as small n, which is our first very important formula for this chapter. The number of moles is the number of particles divided by Avogadro number. Any doubts here? Any doubts? Straightforward? Number of moles will be n, the number of particles which is given to you, divided by Avogadro number. क्योंकि एक मोल में इतने सारे होते हैं, तो कितना मोल बनेगा? That by that. Cool? All right, let's see you solve a few problems. Please open your booklet. Take out class assignment 1. Class assignment 1, please solve problem 1, 2, 3. Please solve problem 1, 2, and 3. First question. How many moles of electrons in 1 kg of electrons? First, you need to find out the number of electrons in 1 kg. And once you know the number, you can calculate number of moles divided by Avogadro number, divide by Na. Right? If you know the number of electrons, then you simply need to divide by Na. That will give you the number of moles of electrons. Please remember, small n will be our symbol for number of moles, always. Right? So that's the first thing to do. So how will I begin? In 9.1 into 10 power minus 31 kg, how many electrons do I have? 1. It is unitary method, no? In this many kg, I have 1 electron. So in 1 kg, I will have how many electrons? This by this, this by this. So this will have 1 upon 9.1 into 10 power minus 31 electrons, which is how much? 10 power minus 31 will go to the numerator. This will become 10 to the power 31 upon 9.1 electrons. This is the number of electrons. Yes, no, this is a lot of electrons. 10 with 30 zeros approximately. Yes, that is the number of electrons. If I hold together, how much will it weigh? 1 kg, right? But I have not been asked the number of electrons. What is the question asked me? Number of moles of electrons. So what will number of moles be? Number of moles will be number of electrons upon Avogadro number. So this will be 10 power 31 upon 9.1 into Na moles of electrons. This is the answer. Yeah, you can leave it like this. It all depends on how the options are given. I hope you realize that in entrance exams, the questions are going to be multiple choice, right? So one of the 4 options you have to select, and depending on how the option is given, you will have to mark your answer. You will practice a lot of multiple choice questions. I will be recommending books to you. I will be giving you homework. I'll tell you also how we will go about all the classes. You should buy, however, a scientific calculator. How many of you are ISC board here? 1, 2, 3, 4. तुम लोगों को तो calculator खरीदना ही है, because it is allowed in board exams. So you need a calculator. CBSE people, I recommend that you buy a calculator, right? I still have my calculator from 2004 when I was preparing for engineering, right? So that is a 15-year-old calculator. It still works. It still works. So it's a lifelong investment. I can recommend 2 calculators to you. You can buy Casio FX 82ms, or you can buy FX 100ms, right? Both of these are good calculators. You can buy any one, but you need to get a scientific calculator. Okay? Right? Is this question clear? Any doubts? Next, question 2. Yes. Question 2. How many moles of helium in this many atoms of helium? Bolo. What is the answer? 20 moles. Yes, 20 moles. See, the number of helium atoms given is 12.044 into 10 power 24 atoms. Right? This is the number of atoms of helium given. The question is asking for number of moles. So number of moles of helium will be number of atoms of helium divided by Avogadro number. Right? So this is 12.044 into 10 power 24 upon 6.023 into 10 power 23. Acha, ध्यान देना. Many times Avogadro number is also written as 6.022. Right? Some books write 22, some books also write 23. So whatever is convenient for you, you can use. If it is 6.022, then you will notice that this goes exactly 2 times. 6.022 into 2 is 12 point this. So this will go exactly twice, and 10 power 23 will cancel. Only 1 10 will be left, so 20. Right? So the number of moles of helium atom is 20. Make sense? Whenever you're solving questions in mole concept, you will get more confidence with time, but I will recommend that you use the proper symbols. Right? For example, here I have written N, which represents number of moles, and uske niche what have I written? He, which represents number of moles of helium atom. Helium atom. Okay, next question. How many moles of ozone are present in 12.044 into 10 power 24 molecules of ozone? Now this is very important. Write down the data which is given to us. 3a. What is given? The number of molecules of oxygen are given. So number of molecules of O2 are given. Ozone, sorry. Number of molecules of O3 are given. How much? 12.044 into 10 power 24. This is given to us. So what will be the number of moles of ozone? Same mathematics, 20 moles. Right? This we understand. If the number of moles of ozone is 20, then what will be the number of moles of oxygen atom? How divide by 3? ऐसे बताओ, एक मॉलिक्यूल ओजोन में कितने ऑक्सीजन एटम है? 3. Ozone is O3. So 1 molecule of ozone is made up of 3 atoms of oxygen. So 1 mole of molecules will be made up of 3 moles of atoms. So 20 moles of molecules will be made up of 60 moles of atoms. Please be confident in this. 1 molecule of oxygen or 1 molecule of ozone is made up of 3 atoms of oxygen. So 20 moles will have 60 moles of atoms. These are 20 moles of molecules. These are 60 moles of atoms. 1 molecule has 3 atoms. Are you getting it? Right? 3b. 3b. What has the question given you? Read the question very carefully. It has given you the number of atoms of oxygen. So what is given to us? Capital N O. The number of atoms of oxygen is given as 36.132 into 10 power 24, right? So from here what can you calculate? From here you can calculate the number of moles of oxygen atoms. You can calculate the number of moles of oxygen atom. How much will this come to? 60. When you divide this by 6.023, this will go 6 times. 6 6 are 36. So 60 moles. Which means, how many moles of ozone do I have? 20. Same ho gaya na? Right? So this oxygen which I have represented, I can call it this many molecules of ozone. I can call it 20 moles of ozone. I can also call it 60 moles of oxygen atoms. All of it are representing the same quantity of gas. Yes. What will be the weight? What will be the weight of oxygen here? What will be the weight of oxygen? Okay, we'll come to this. We'll come to this. Is this part clear? Right. Next. 3C. Let's do 3C. How many electrons? Please solve. Tell me the answer. How many electrons in the above sample? I have 20 moles of ozone gas, right? The number of moles of ozone gas is 20, or the number of oxygen atoms is 60, right? How many electrons are present here? Please solve. All right, let's understand. In one atom of oxygen, how many electrons do we have? 8. Right. We have 8 electrons. In one single atom of oxygen, I have 8 electrons. So if I have 1 mole of oxygen atom, how many electrons will I have? 8 moles. I'll have 8 moles of electrons. But how many moles of oxygen atom do I have? 60. So 60 mole, unitary method. 60 mole of oxygen atom will have 480 moles of electron. Not 480 electrons. I'll have 480 moles of electrons. Right? If someone asks you the exact number, you can say 480 into 6.023 into 10 power 23 electrons. That many I will have. Or you can obviously represent it in moles. The answer is 480 moles of electrons, or you can write it like this, 480 Na electrons. You can also write it as 480 Na electrons. Make sense? Next. Question 4. 3 moles of H2SO4. I have 3 moles of H2SO4. See what is given to me. Number of moles of H2SO4 is given as 3. Right? This is given to us. What is asked? Number of hydrogen atoms. Number of moles of hydrogen atoms will be how much? If I have 3 moles of sulfuric acid, then how many moles of hydrogen atom will I have? 6 moles. 6 moles, right? Because in every molecule there are 2 hydrogen atoms. So 6 moles. How many moles of oxygen atom will I have? 12 moles. Yes? Straightforward? I have 6 moles of hydrogen atoms or 12 moles of oxygen atom. Okay. Now, we'll come to the second formula of this chapter. Let me ask you a question first. What is your weight? Anyone here knows their weight? Batao, what is your weight? 55 what? Wrong. That's not your weight. That's your mass. How is weight measured? In newtons. So how much is your weight? 55 into 9.8 meter per second square. Yeah, 10 approximate kar lo, 10. So how much is your weight? 550 newtons, right? Your mass is 55 kg, but your weight is 550 newtons. So next time someone asks you your weight, don't tell them in the wrong unit, right? Kg is the unit for mass. Newtons is the unit for weight, right? Now, if you're a physics student, then this is an important difference. But chemistry mein kya hoga? I will be using it interchangeably, right? The symbol for mass of a substance in most books, mass of substance will be used as small m, but I will be using W. ठीक है, अभी केमिस्ट्री के पर्सपेक्टिव से मास और वेट क्या है? सेम है. ठीक है, मतलब सेम नहीं है, यू नो सेम नहीं है, बट कई बार ऐसा होगा, आई विल से कि द वेट ऑफ कैल्शियम कार्बोनेट इज 50 ग्राम. So when I say 50 gram, I mean the mass of calcium carbonate which I'm giving to you, the mass of the substance, not the weight, because weight is measured in newtons, but we'll not be doing that, right? So the weight or the mass of a substance, the symbol in most books will be small m, but I will be using W. I will be using small w in my class. There's a reason for that. There's a reason for that. You'll understand very soon. Okay. Write down a definition. Molar mass, capital M. Write down the definition. Molar mass, capital M. Okay. The mass of 1 mole of a substance is molar mass. The mass of 1 mole of a substance is molar mass, right? Anything which I have, okay? If let's say this pen is 5 grams, right? If I have 1 mole of these pens, matlab, if I have 6.023 into 10 power 23 such pens, then the mass of that is the molar mass. Any substance which you have, if you take 1 mole of that substance, then its uska jo mass hoga, that will be the molar mass. So we can have 2 types of molar mass. Molar mass is generally represented in grams, is generally measured in grams. It could be gram atomic mass, or it could be gram molecular mass. It could be gram atomic mass or gram molecular mass. What does gram atomic mass mean? The mass of 1 mole of an atom. That is gram atomic mass, measured in grams, And gram molecular mass is what? The mass of 1 mole of a molecule. That is gram molecular mass. So if I ask you, what is the, let me write it like this. The molar mass of helium is effectively what? It is the mass of 1 mole of helium, right? And how much is this equal to? How much is this equal to? The molar mass of helium is the mass of 1 mole of helium. How much is this equal to? 4 grams. 2 प्रोटॉन 2 न्यूट्रॉन. एक एटम हीलियम कितना है? 4 AMU. तो एक मोल हीलियम कितना होगा? 4 ग्राम, right? 4 ग्राम. Yes. The mass of 1 mole of oxygen will be how much? 16 gram, and so on. This you can understand. Gram molecular mass would be, let's say, mass of 1 mole of a molecule, let's say water. Mass of 1 mole of water. How much will this be? 18 grams. Yes. This is going to be 18 grams. Make sense? Now this is a very feasible unit. If I have a bottle of water, it is approximately 1000 grams, right? So you can calculate the number of moles of water in that one bottle. Anyway, mass of 1 mole of water is 18 grams. What is mass of 1 mole of sulfuric acid, H2SO4? Mass of 1 mole of sulfuric acid? 98 what? Grams. Yes. See, oxygen is 16. So 16 fours are 64. Plus sulfur is 32. 64 plus 32, 96. Plus hydrogen is 1. So 98. This will be 98 gram. And so on. Right? So the mass of 1 mole of any substance is its molar mass. I can have gram atomic mass. I can have gram molecular mass. And what is the utility of this now? Utility is, think reverse. Suppose I give you 8 grams of helium. In a container, I fill 8 grams of helium and I give it to you. How many moles of helium have I given you? 2 moles. Right? So if I give you the weight, if I give you the weight and I ask you how many moles I've given to you, you can do that calculation easily. 4 grams is 1 mole. So 8 grams is 2 moles. I give you 20 grams of helium. How many moles have I given you? 5 moles. What are you doing? Weight divided by molar mass. Weight divided by molar mass, which brings us to the next very important formula. Number of moles is weight by molar mass. Number of moles is weight by molar mass. The second most important formula in this chapter. I can give you an amount of substance and I can ask you number of moles of that substance. All you need to do is divide by molar mass. That will give you number of moles. Yes? Okay. Please solve. Question 5, A, B, C, D. Alright. The weight of oxygen given is 32 grams. What is the molar mass of oxygen? 32 grams. 32 grams. So number of moles is how much? 1. Right? Number of moles of what? Number of moles of O2 is 1. right? So how many moles of oxygen atom do I have? 2. The number of moles of oxygen molecule is 1. So the number of moles of oxygen atom is 2. Yes? Okay. The weight of calcium carbonate given is 100 grams. What is the molar mass of calcium carbonate? 100 grams. You must say the unit always. 100 grams. So number of moles is 1. The number of moles of calcium carbonate is 1. What is the molar mass of urea? Please calculate. This is urea, NH2CO, NH2. This is the compound urea. The weight given to you, I have given you 120 grams of urea, but the molar mass is how much? 60. 60 grams. देखो 2 nitrogen है. So 2 into 14 plus. I have 4 hydrogens. 4 into 1 plus. I have 1 carbon. 1 into 12 plus I have 1 oxygen. 1 into 16. Right? If I add all this, it comes to 60. The molar mass of urea is 60 gram. So how many moles of urea do I have? 2 moles. Yes. Next, 5D. 6 moles of helium. 24 grams is the weight given to us. The molar mass is 4 grams, so 24 by 4, 6 moles. Is this formula clear? So if I give you the weight of a substance, you should be able to give me its number of moles. The formula we will use is weight by molar mass. Yes? Any doubts here? Clear, right? Okay. Heading. Avogadro's law. Write down. Under similar conditions, of pressure and temperature, equal volumes of all gases, of all ideal gases, under similar conditions of pressure and temperature, equal volumes of all ideal gases contain the same number of molecules. Underline molecules, please. Under similar conditions of pressure and temperature, equal volumes of all gases contain the same number of molecules. Underline molecules. Let's understand what Avogadro is saying. I take 4 gases. Right? Let's say oxygen, helium, methane, SO2. Right? I've taken these 4 gases and the pressure and temperature is same. In all the containers, the pressure is same, the temperature is also same. Now, Avogadro is saying, if this is the situation, then if the volume of these is also same, if the volume of these containers is also same, if they have equal volume, then they will definitely have equal number of molecules. They will have equal number of molecules. So if number of molecules of oxygen is, let's say, capital N, then all of them will have N molecules. This is Avogadro's law. Under similar conditions of pressure and temperature are same. Under similar conditions, equal volumes of all gases, all ideal gases, will have equal number of molecules. Now, if number of molecules are same, then the number of moles of the molecules are also same. Right? Number of moles लिये क्या करते हैं? If number of particles are given, we divide by Na. Right? Number of moles will be N by Na. Will also be N by Na. This will be N by Na, same. Right? Which means that under similar conditions of pressure and temperature, equal volumes of all gases will have the same number of moles. Of what? Of molecules. Right? Say the pressure, temperature and volume are such Say the pressure, temperature and volume are such that the number of moles is 1 mole. Say I have 1 mole of oxygen. This means what? How many moles of helium will I have? 1 mole, right? This will also be 1, this will also be 1, right? What will be the weight of this container? If I put it on a weighing machine, ignore the weight of the container, only the weight of the gas if I want to calculate. What will be the weight of 1 mole of oxygen? 32 grams, yes. What will be the weight of 1 mole of helium? 4 grams. ये different है अब. 1 mole of methane, 12 plus 4, 16 gram. 1 mole of SO2, 64. Oxygen is 16, 16 to the 32, sulfur is also 32, 32 plus 32, 64 gram. Right? Isn't this fascinating? These containers have the same pressure, the same volume, the same temperature, the same number of moles, but the mass is different. This is 32 gram, this is 4 gram, this is 16 gram, that is 64 gram. This is Avogadro's hypothesis, Avogadro's law in fact now, right? Equal volumes of gases will contain the same number of molecules, and that's why I made you underline molecules, right? I have how many molecules here? 1 mole jitna molecules hai, but how many atoms do I have? 2 moles. I have 2 moles of oxygen atoms. Over here, I have 1 mole of helium, and how many atoms? Also 1 mole. How many atoms do I have here? 5. I have 1 mole of methane gas. I have 5 moles of atoms. उस 5 मोल में 4 मोल हाइड्रोजन का है और 1 मोल कार्बन का है, right? How many moles of atoms do I have here? 3. So they have different number of atoms, but they have the same number of molecules. They have different number of atoms, but they have the same number of molecules. That is why the term molecules is very important in Avogadro's law. Under similar conditions of pressure and temperature, equal volumes of any gas, all gas, will contain the same number of molecules. We will understand this in much more detail when I teach you gaseous state. Gaseous state is another chapter in physical chemistry. That's after 2 months. After 2 months. Any doubts here? Clear here? Now, how does this link up to mole concept? And how you will be asked questions related to this? Let me explain. Make a note. Under standard conditions, of temperature and pressure, under standard conditions of temperature and pressure, 1 mole of any ideal gas, under standard conditions of temperature and pressure, 1 mole of any ideal gas will occupy a volume of 22.4 liters. Under standard conditions of temperature and pressure, 1 mole of any ideal gas will occupy a volume of 22.4 liters. Standard conditions of temperature and pressure is written in short as STP. At STP, 1 mole of any gas, the volume is going to be 22.4 liters. Now what is STP? I'll just, standard temperature is 0 degrees Celsius or 273 Kelvin. This is standard temperature. Standard pressure, yes, 760 millimeter of mercury you can call it, or it can be written as 76 centimeter of mercury. This is also correct. Or I can call it 1 atm. atm is a unit of pressure. 1 atmosphere. ये कैसे आता है ये हम बाद में देखेंगे. Or what is the SI unit of pressure? Pascals. Yes, it is newtons per meter square. Pressure is force by area, right? Force is measured in newtons, area is meter square. So in pascals, this is 1.013 into 10 to the power 5 pascals, right? They are the same pressure. These are just different units of pressure. You can measure it in millimeters of mercury, centimeters of mercury, atmospheres or pascals. We can also measure it in bars, right? There are many units for pressure, but 1 atmosphere is almost equal to 1 bar, but then there are small differences. We'll see that later, right? But the point here is that if the condition is standard, that is 273 Kelvin and 1 atm pressure, if this is the condition, then any gas, if I take 1 mole of that gas, how much volume is it going to occupy? 22.4 liters, always, right? Which brings us to the third important formula of this chapter. Think of it in reverse now. Okay? If I give you 22.4 liters of a gas at STP, how many moles of that gas do you have? 1 mole. If I gave you 44.8 liters of that gas, 2 moles, and so on. So the third formula is number of moles is volume upon 22.4. Volume at STP divided by 22.4. Yes or no? This is the third formula for number of moles, right? So I will summarize today's class with the help of a Y map. In the center, I have number of moles represented by small n. Okay. The first formula which we saw, if I have number of particles, it could be particles of anything, right? If I have number of particles represented by capital N, how do I convert number of particles to number of moles? How do I convert number of particles to number of moles? Divided by Avogadro number? Yes, right. So from here to here I can go by dividing by Avogadro number. So number of moles can be converted into number of particles by multiplying by Avogadro number. Make sense? This is the first formula we saw today. Then second, if you are given the weight of substance in gram, represented by the symbol W. I like to represent it as W. So if weight is given and number of moles is asked, how do you do? How do you convert it to number of moles? We divide by molar mass. 4 gram of helium is 1 mole, 8 gram of helium will be 2 mole, 20 gram of helium will be 5 moles, etc. We are dividing by molar mass. Yes. And if number of moles is given and you want to get weight, what will you do? You will multiply with molar mass. You will multiply by molar mass. Make sense? This is the second formula we saw today. And the third formula is if volume of gas at STP is given to you, and this should be in liters, the symbol I will use is V. Then this can be converted to number of moles. All I have to do is divide by 22.4. Or if number of moles is given and volume is required, multiply by 22.4. Okay. This is everything we studied today. There is a summary of today's class in one single diagram, and this is extremely useful. If you always refer to this diagram and if you always write down the symbols properly, okay, you will never make a mistake in mole concept. Let me give you an example. Answer this question for me. Tell me. What is the weight of 11.2 liters of ammonia at STP? I have given you the volume of the gas. I am asking you the weight of the gas. Understand? अब देखो ये map इसलिए यहाँ काम आएगा. Where what have I given you? Yes, good. I have given you volume, and what have I asked you? Weight. So you cannot jump directly from here to here. What must you go through? Moles. Right? All roads go through moles. I have given you volume, you cannot directly jump to weight. How much is the volume? 11.2 liters. So how many moles will I have? From here to here, what do you have to do? Divide by 22.4. So I have half mole of ammonia. Yes. But from here to here, what do I have to do? Multiply by molar mass. What is the molar mass of ammonia? 17 what? Grams. मोलर मास मतलब एक मोल अमोनिया का वेट पूछ रहे हैं ना, सिर्फ 17 तो कुछ भी हो सकता है, right? The molar mass of ammonia, 1 mole of ammonia weighs 17 grams. How many moles do I have? Half mole. So the weight will be what? 8.5 grams. Do you see how this is helping? Right? The volume of NH3 is 11.2 liters. So number of moles of NH3 is 11.2 upon 22.4. This is half mole. I have come here. From here to here, I need to multiply by molar mass, that is 17. So the weight of ammonia is going to be number of moles of ammonia multiplied by molar mass of ammonia. So this is going to be 0.5 into 17, 8.5 grams. Okay, tell me this then. How many atoms of oxygen in 44.8 liters of ozone? Please solve. How many atoms of oxygen in 44.8 liters of ozone? I have given you this data. Huh? Yes. Excellent. 44.8 liters of O3. Write down the data. Volume of O3 given is 44.8 liters. So the number of moles of ozone is how much? 2 moles. Right? So you immediately come here. Right? Now, if you have number of moles of ozone, then you know number of moles of oxygen atom. How much will this be? 6 moles. This is 6 moles. So what will be the number of oxygen atoms? 6 into Avogadro number. This is the answer. Yes, good. 6 moles, 6 into Na. That is the number of oxygen atoms you have. Are you getting it? तुम यहाँ से direct इधर नहीं jump कर सकते थे. You have to go through moles. You have to go through moles. The moles is linking number of particles, weight and volume. That is what the mole is doing. Yes? Okay. Try problem 6. I hope all of you know this formula. Density. What is the formula for density? Mass by volume. But what symbol am I using for mass? W. Right? It is mass by volume. Density is mass by volume, but यहाँ mass और weight chemistry class के लिए एक बराबर. So I will be using density is weight by volume, W by V. ठीक है. Okay. Tell me now. Solve question 6. Solve question 6. Calculate the number of water molecules in 54 ml of water at 4 degrees Celsius. The density is given as 1 gram per ml. ये liquid water है. Look at the temperature. The temperature is 4 degrees Celsius. At 4 degrees Celsius, what does water remain? Liquid. Water is liquid. This is valid only for gas. Please note, 1 mole of a liquid does not occupy 22.4 liters. 1 mole of a gas at STP occupies 22.4. This is only valid for gases, not for solids and liquids. Okay. 100 degree, 4 degree दिया हुआ है ना. So water किस में form में होगा? Water will be in liquid form at 4 degrees. You don't need this branch here. See, calculate the number of water molecules in 54 ml of water. The volume of water, liquid, is given as 54 ml. The density is also given 1 gram per ml. So what is the weight of water? Weight is what? Volume into density. Right? So how much is the weight? 54 gram. If I know the weight, then I know the number of moles. How much is the number of moles of water? Number of moles of water. Molar mass of water is 18 gram. 3 moles. Yes. I have 3 moles of water. Yes. But This is 3 moles of water, what? Liquid. 3 moles of liquid water is occupying how much volume? 54 milliliters. If I ask you this question, if I tell you that the number of moles of water vapor gas is also 3 moles, right? इसका weight कितना होगा? वही होगा 18 ग्राम, sorry 54 gram. Yes or no? 3 moles of water gas will also weigh 54 gram. But what will be the volume? What will be the volume of 67.2 liters? It will be 3 into 22.4. 67.2 liters. And observe this. जब water liquid था, how much was the volume? 54 ml. The same water, it is the same water, is it not? 3 moles. The same 3 moles of water, if I convert to gas, its volume is how much? 67.2 liters. How many times has the volume increased? 30,000 times the volume has increased. Yes? Why does this happen? Why does this happen? Intermolecular distance. You might have studied this. In solids, the atoms are very close together, the molecules are very close together. In liquid, they are farther away. In gases, they are very far away. So when any substance converts from liquid to gas, its volume increases incredibly. The volume increases many, many times, right? The same thing we can see with water. 3 moles of water, which is 54 grams of water. When liquid, it was 54 ml. But when it is converted to gas, it is 67,000 ml. Are you getting it? 20,000 times the volume has increased because the distance between the water molecules increases. Is it okay? Is this Y map clear to everyone? Whenever you're solving problems, mole concept, if you refer to this Y map, you will not make a mistake. And if you write down the data with the proper symbols, you will have less chances of mistake. Is it okay? All right. Please attempt class assignment 2, problem 1. This is the last question for today. If I have one atom of n minus 3, how many electrons will it have? 10 electrons. See, because nitrogen on its own has 7 electrons, and if it is minus 3 means it has 3 extra electrons. So 7 plus 3, this has 10 electrons. Right? One atom of n minus 3 has 10 electrons. And what is the weight of one atom of nitrogen? 14 what? नहीं यार, एक atom का पूछ रहा हूं. 14 what? AMU. This is the scene. One atom of n minus 3 has 10 electrons and its weight is 14 AMU. So if I take 1 mole of it, if I have 1 mole of n minus 3, how many electrons will it have? 10 moles of electrons? Yes or no? It will have 10 moles of electrons, and what will its weight be? 14 grams. Its weight is going to be 14 grams. Any substance, if I take 1 mole of that, its weight is the same in grams, right? But what is the question asking for? 28 grams. The question is saying 28 grams of n minus 3 will have how many electrons? So if in 14 gram I have 10 moles of electrons, then in 28 grams I will have 20 moles of electrons. You said 20, which is wrong. 20 electron or 20 mole electron में बहुत फर्क है यार. Right? The answer is not 20, it is 20 moles of electrons. Right? Number of electrons, if exact you have to calculate, then the number of electrons will be 20 into Na, meaning 20 into 6.023 into 10 power 23. This is the answer. These many electrons are present in 28 grams of n minus 3. Are you getting it? Cool. Okay. We'll stop here today. Right? It was a very, very straightforward, very, very basic class today. ऐसा नहीं है. This is not what preparation is going to be like. But since it was your first class, I've kept it simple. Now, in case of chemistry, every chapter is divided into 4 parts. First, there are class assignments. Okay? All the problems in the class assignments, I will be doing them in class. Okay? After the class assignment, you'll notice there's a home assignment, right? Now, there are two home assignments in the chemistry booklets, home assignment 1 and home assignment 2. Home assignment 1 is divided into sections, right? And these sections are essentially topics. So after every class, I will be giving you homework. So the homework for today is just section A. That's it. Home assignment 1 ka section A. That is all you have to do. Just 10 questions. That's all. You'll notice some questions have a star mark. Those questions basically have more than one correct answer. But you need to start practicing multiple choice questions. So home assignment 1, section A, 1 to 10. This is your homework. Section B, C, and D, etc. we will start in the next class. So that you will do then. Home assignment 2 basically has concepts from all the topics in the chapter. So once I have finished the chapter, then you will be required to solve home assignment 2, right? Acha, home assignment 2 ke baad, you will notice I have given you some subjective questions. These are important from JEE advanced point of view. Because in advance you get more complex questions, so subjective questions will help you there. And then I also have board level questions. Board level questions. If mole concept is coming for your school exam, then you can just revise these board level questions and go. Right? That will help you in school exam. And these are followed by the answers. Okay. After that is the second part of this booklet, which is equivalent concept. Right? So this booklet has two chapters actually in it, mole concept and equivalent concept. Right? This together is called stoichiometry. But so today's class was pretty straightforward. Yes. Homework is also very little. You just have to do section A 1 to 10. Right? You have to buy one other book apart from this for problem solving. Like I said, there are 3 branches of chemistry. I will be recommending 3 books to you only for problem solving. For now, you need to get this. Problems in numerical, problems in physical chemistry. This is by N. Avasthi. Sri Balaji publication. Right? Problems in physical chemistry, N. Avasthi, Sri Balaji publications. Okay. If you want a strong hold on any chapter, you need to solve. This book does not have theory. It only has problems. Her chapter pe there will be around 500, 600 problems. And there are 35 chapters. I'll be recommending 3 books. You have to solve around 50 to 60,000 problems. Okay, in the course of the next 2 years, and then you will be set. It is very straightforward. जितना homework मैं दे रहा हूँ, जो मैं करने बोल रहा हूँ, if you keep finishing that, it's going to be smooth sailing. But if you let it pile up, right? अगर backlog होते रहेगा, तो फिर आगे का class में फिर वो घबराहट होने लगता है, फिर लगेगा अरे अब तो नहीं हो सकता. Then all those things start to come in. But if you stay on track, if you keep solving religiously, you will get through. ठीक है. Do you have any questions?